Hi guys, let's solve this question. Guys, first I can read the question. Use Laplace transforms to solve the differential equation. So guys, we have our differential equation there. And then given that when t is equals to 0, y is equals to 3, dy dt is equals to 4. So guys, we start off by I have already started off, and this is what I have started off by writing. So guys, this is our equation here, and we have the conditions that are given. For us to be able to do this question, guys, we can use these formulas, and these formulas are for Laplace transform. For Laplace transform of a derivative of t, that is second derivative, this is what you get, guys. We have that equation for that. For the first derivative, we have this equation. And so guys, we are now going to now look at the equation that we have. Maybe I can still write it down here. So guys, this is my equation. And now I can now replace for the second derivative. For the second derivative, guys, I'm going to write this. And remember the ft, this is supposed to be y. And so therefore, we are going to have s squared Laplace transform of y, this is now y, minus s f0, that is the initial condition, minus the initial condition for first derivative. Now plus, we can now write plus 4, we can put a bracket there. For the first derivative, Laplace transform of first derivative is s, Laplace transform y, minus f0, like that. Now plus 3, and of course here is the Laplace transform of y. This guys should be equal to Laplace transform of e raised to negative 4t, like that. So with that guys, we can now go ahead and do the question as necessary. So guys, using our conditions, we are going to replace for our conditions. These are our conditions. So let me write s squared first, then Laplace transform of y, minus, we have s, and our first condition guys is when we have t equals to 0 for the initial condition, and that is for y. This is for y. For this one is supposed to be for the first derivative. So for y, then this is going to be 3. And so therefore, guys, I'm going to put 3 in the place of f for the first condition. So I'll put 3 there. Minus, maybe I can put it like that. We have the initial condition for the first derivative, which is now given as 4. So guys, I'll put 4 in place of f prime 0. So I put 4 there. Plus, now I also put 4. And remember that this 4 is multiplied by s Laplace transform of y, minus, we also multiply here by 4 before we replace, because remember this bracket was up to that point. And so therefore I can write minus 4, and then I can now replace for my f0, which is now supposed also to be 3 like this. So that is 3. Guys, from there, we come to the final, which is plus 3, Laplace transform of y. This is now equal to, we can look for Laplace transform for that, and this one is given by 1 all over s now plus 4, since it's negative there. That is the Laplace transform for exponential e raised to a number and then t. So the number now, if it's negative, you write positive. So guys, that's what we have now as our equation, and now I can continue. So guys, I can write it in properly. Now s squared Laplace transform of y minus 3s minus now 4 plus we have 4 s Laplace transform of y minus, this is now 12 plus 3 Laplace transform of y. This now is gives us 1 all over s plus 4. So guys, we still continue. We now come guys and factor out Laplace transform of y. So if I factor out Laplace transform of y, I'm going to be left with s squared for that. Then we have here 4s, because it's together with the Laplace transform of y. This is plus 4s. And then we also have this 3. So guys, I have been able to factor out the Laplace transform. Then I shall be left with, here we have negative 3s and negative 4. So, and then we also have 12. So negative 4 plus negative 12 is 16. So guys, we shall be left with negative 3s, negative 16, which now gives us 1 over s plus 4, like that. Guys, now we can put this on this other side. These values, we can put them on this other side. So we are left with Laplace transform of y, s squared plus 4s plus 3 minus, we are going to put them there, so we have 1 over s plus 4, that is now plus 16, or plus 3s plus 16, like that. Guys, we now continue. From there guys, we can actually now combine this with that. So if we combine guys, we are going to have, that is putting them under the same denominator of s plus 4. Guys, by evaluation of that, I've already done it, and it brings about 3s squared plus 28s plus 65. So that is what you should get, guys, if you were to put all of these under the same denominator. So guys, we are now having that Laplace transform of y, s squared plus 4s plus 3, like that. So finally guys, we can now be left with the Laplace transform on one side, and then we can now put this one under that. So we shall have Laplace transform of y equals to 3s squared plus 28s plus 65. And so guys, we are also going to bring this side. So we are going to have s plus 4, and then guys, we are going to have s squared plus 4s plus 3, like that. So after finding that, guys, for us to be left with y alone, we need to get the inverse Laplace transform there. And also here we get the inverse Laplace transform. And so guys, we are left with y on this side, and then we come and now do inverse Laplace transform on this side, which is now I can write like that: 28 either s plus 65 all over s plus 4 s squared plus 4s plus 3. So this is what now guys we are going to look for. That is the inverse Laplace transform for that. And so guys, here I have the video I did. This is the title for the video I did last time. And if you check this and that, you find that they are similar. So guys, check on this video and find out what I got or how I did it. But my answer now came to y. Can write the answer for you y, but you can go back to this video and be able to see how I did it. So y is now equals to than e raised to negative 4t, that's what I found, minus 4e raised to negative 3t plus 20 all over 3 e raised to negative t. So guys, that is how I did the answer that I found while I was doing this problem. So please go and check for that video. And guys, God bless you so much. Bye bye.